You are now in the Reality Capture Network.
All right, welcome to the Reality Capture Network. We are excited today to be talking again about new technologies and specifically within construction and prefabrication. And Brent and Chris, we are excited to have you guys with us. So thanks for joining today.
Thanks, Matt. Appreciate the invitation. Yeah.
For sure. All right. So we always like to start with, of course, talking about, well, who is our guest today? And we normally have one. We've had two a couple times, and today we've got two. So let's start out by, we'll just go one at a time. Let's hear a little bit about you guys. I really like to know, and of course, let our listeners know. Who are you? What's your background? Where'd you grow up? Some of the personal side, but then what led to, bringing you into the industries, you're in and where you're at and where you're going. So maybe Brent, let's start with you and then we'll go to Chris.
Yeah, no, thanks, Matt. Appreciate it. So I'm a senior account manager at FARO Technologies. FARO Technologies is based in Lake Mary, Florida. We're well known in the AEC market segment, public safety market segment, 3D metrology. I got one of the iconic things here behind me. So a little bit about myself. I've been at FARO almost 5 years. Came on board from a previous role where I was doing 3D scanning and working with some other metrology technology and typical construction layout equipment. My background's in civil engineering and surveying. Have a degree from Purdue University, so go Boilermakers. And, I started in this industry back in 2008, right out of high school, got into surveying and it was an interesting time back then, right, with the housing market crashing and the economy sort of going down. And I ended up finding myself into a new role where I got introduced to the laser scanning technology. And it kind of just took off from there. There was a brief time I was actually, I went back more to the civil engineering side of the world and got away from scanning for about a year, and God, did I miss it. So yeah. My family and I ended up coming back up north. We were down in Florida for a year and got back into my old role and then ended up coming over to FARO and here I am today. But over the last year or so, I've really been in this focus of this prefabrication, modular construction. It's a really interesting area that is just now getting sort of the spotlight it deserves, where it hasn't always in the past. And what's funny about it is it's nothing new, right? And as we'll allude to that later in the discussion, what's awesome about FARO and this industry that we're focusing on today is it's nothing new to us. If you think of FARO before scanners, it was our 3D metrology systems manufacturing, right? So what's awesome is we have this breadth of folks who are engaged in this, who have experience, and we're able to take that knowledge and bring it into the construction world, and it's really been going really well. So looking forward to discussing it with you guys, and thanks again for having us on today, Matt.
That's awesome. Yeah, thanks, Brent. Awesome. And Chris, let's go over to you.
Sure. Thanks again for inviting me on, Matt. So I'm from Canada. Grew up just north of Toronto. Big hockey boy growing up.
Mm-hmm.
During school, I kind of gravitated towards the maths and sciences. Actually wasn't sure what I wanted to do career-wise, but was steered towards engineering as sort of a good, stable career path. So I went to the University of Waterloo for civil engineering, did my undergrad there. And it was a great program. It was co-op based, so you had a lot of placements kind of interspersed throughout the learning semesters. Got me kind of across the country, and actually did a placement in Germany as well. So I've got, it was a great opportunity for me just to kind of see the world of engineering. Mm-hmm. I did everything from sort of bridge engineering consulting, worked in the oil and gas sector for a little bit, and then naturally gravitated towards research and development. So I had the opportunity to do an accelerated master's program out of my undergrad, and was working with one of the most prominent professors who's doing research in this sort of laser scanning space. Carl Haas, he's been doing kind of research in this area for probably about 20 years, and even before the sort of modern kind of era of laser scanning. But in a lot of his research, he was using it as a way of kind of quantifying and tracking progress on construction sites. And so during my master's degree, I focused on how we can use this technology specifically in modular construction. And as we'll get into some of the more nitty gritty details, my research focused on developing an overall framework for how to manage tolerances in modular construction. It's a very important component to this kind of construction for making sure that things fit properly. Yeah. So I did a bit of research in that area. After my master's, I worked for a couple of years as a computational design specialist. So developing algorithms for BIM-based workflows, as well as incorporating laser scanning into that. So that was pretty cool. I can talk a bit more about that later. Wasn't fully satisfied with my career down that track, and I had an opportunity to go back to Waterloo to do my PhD. So kind of went back to do sort of a victory lap, if you will, of my master's. Mm-hmm. And so that's currently where I am right now. I'm wrapping up my PhD. And again, I'm kind of focused on this whole modular prefabrication space, and kind of looking at how development of algorithms and laser scanning and reality capture can be used in an optimal way to really drive productivity in this area. Yeah. So
that's awesome.
It's been a great experience so far.
Yeah, that's awesome. Yeah, I often get asked, just with being, we're trying to be at the front of sharing information about new technologies. I often get asked, like, what's the next big thing? And, where's the future? And like you're talking about with the research and algorithms and software and utilizing the data, I think that's the next needed area. I don't even think the hardware has to improve a ton for a while. I think the software and how the data can be improved is where it's kind of an open book. I mean, from one software to the next, they do such vast things. I think continuing to get people to focus there would be great.
I can tell you we're definitely working on some things at FARO. We've identified that there's a needed connectivity between software, right? And I think you're seeing that with all sorts of different technology, right? Especially in our industry with Procore and Autodesk and Bentley. And, we're recognizing that from our perspective on the prefabrication side, as we see more and more clients working with, Manufacton and even SolidWorks, right? Software products that you don't normally cross paths in construction. Being able to more easily integrate those to make it a little bit more seamless and more automated. And that's definitely something we want to talk about today, because it's the software side's huge, but so is the automation side, especially in manufacturing, aside from laser scanning and all that stuff. So,
yeah. So, I know our focus, I think, is going to be around, like we talked about, the manufacturing, prefabrication, in construction, the use of technologies. Can we start kind of with the basics from either of you guys' perspective? There's a lot of people that don't even understand why prefabrication and why are things going modular, and what's some of the push for that?
I think there's two sides here, right, Chris? I think I'll be able to tell it from a side of from the salesman approach and what we're seeing. And I think you'll be able to tell it from sort of the side of the research and development. You want to start on your side first?
Sure. Yeah.
Okay.
I think we're kind of witnessing a renaissance of sorts, which is really interesting. So I always go back to talking about kind of right after World War II, there was a huge need to address housing shortage, not unlike what we're seeing today.
Yeah. And
I think there was a lot of, at that time, you'd see sort of where the automotive industry was just sort of past the bell curve, if you will, of just figuring out how to get scaled manufacturing kind of working for the automotive industry. And I think a lot of people looked at that as being, okay, we have this huge need. We need to build houses. how can we harness this technology and what we're doing in automotive specifically and apply that to the housing industry. And unfortunately, while there was a lot of good attempts, this sort of idea of using prefabrication and manufacturing technology, a lot of people said it failed at that time. And I think it was because, while there's a lot of housing being pushed out, it wasn't done properly. And a lot of the benefits you get from doing offsite manufacturing are just based on economies of scale. So if you look at building a house on typical, stick build, as we call it, where you build it on the construction site versus an offsite manufactured house. And I mean, I say houses, but it's buildings, it's any kind of asset, really. Mm-hmm. Think of someone doing a work, and then after that task, someone else has to come in to do that. The next thing could be putting windows in once the framing is done. And you have this very linear process of construction where it's one trade, then the next, then the next, then the next. And in offsite manufacturing, you can get all the trades working simultaneously. So you can get the guys doing windows, and as long as there's a production sequence, you can have in theory, a lot of productivity savings just by being able to parallelize your processes. And so trying to reap the benefits of economies of scale is what has driven the need for offsite manufacturing. And going back to sort of right after World War II, it was the quality component that really failed. And so there was a lot of, housing stock that was being pushed into the market, but it wasn't really being done properly. And kind of fast forward to where we're at today, I think the technology has dramatically accelerated, and there's a lot new focus and ability to do things correctly this way. But the drivers are still the same. Having things done in an offsite facility allows you to take weather out of the equation. It allows you to stack both the foundation work, for instance, as well as working on the actual building or whatever asset you're making. You can parallelize processes. And so a lot of the drivers are, it's faster, higher quality, and it's cheaper. And I think the last thing we can definitely kind of focus on, because I'm sure Brent and I have, a very unique angle. I would say for a long time, people were kind of proclaiming that, modular construction is cheaper because of, reasons X, Y, and Z. And I don't think we're quite at that point yet. And I think there's a real role that technology, such as laser scanning, has to play to get us there. But the real big benefit right now is just getting buildings built faster, which then makes companies more profitable. If they can open up a building sooner, that's a faster kind of time to market. Yeah. So, I mean, I could talk about this for days. Brent, you got to just jump right in here and sort of fill in some more details.
Yeah, I think, some of those points, I think one of there's a couple of things here, right? Construction has always had this perceived viewpoint of we're behind in technology, right? And I think the construction industry has ramped up quite a bit, especially on the field side, right? With drones and laser scanners and robots and, other equipment, right? If you look at bulldozers with the rovers on them, GPS systems for grading, right? Those are the things we've seen evolved. I think one of the things I've learned as I've divulged into this industry is that it's funny you mentioned most people think that modular and prefab is cheaper. And I think it depends on the project, right? There are some projects where it makes more sense to do modular. There's some where it doesn't make sense, right? And I think one of the other misnotions, and I was guilty of it at first, was I always thought modular was we're only looking at a new building, right? Or prefab, we generally think of a new building. No, that's not the case. If you look at cities like, where I'm at near Chicago and New York and even up in Canada, some of these older cities where these buildings are being renovated, right? Those are huge opportunities to use modular prefabrication, right? We integrate the 3D laser scanning system to get a full, complete as-built, because everybody knows, especially in Chicago, the drawings aren't up to date. There's always some hidden closet or something in there that wasn't picked up that throws something off. And then we can take these other technologies and help with that process. And then we bring that into this modular arena, and we're able to build these bathroom pods or these office spaces, or even in this COVID era, these medical rooms, right? Where we can do it safely, we can do it faster. As Chris was saying, there's no weather involved. How we work with the trades can be more efficient, right? And there, and like Chris said, we could talk about this all day. There's topics of, how do you address the labor shortage? How do you have multiple trades work together in regions where, like Chicago, is heavy unionized, and in other regions it's not? And it's a really interesting area to focus on and see. And I've learned a lot over the last year and a half, and it's incredible, right? I know one thing we didn't talk about was how did Chris and I meet? Right? Why are we talking to each other? What is the interest here? And it's actually been a really awesome adventure for Chris and I over the last year or so. I didn't know who Chris Rausch was a year ago, and I got introduced to him through a colleague of mine who works on our Build It team. And maybe Chris talk about some of your research, but through that research project that Chris is finishing up with his PhD, we work together from a company perspective, and some of that R&D work with using the laser scanning technology and some of the QAUC practices that you see today, and also with what Chris is working on. So that's where we got started. From my side, Chris is someone I enjoy speaking to whenever possible. We talk quite a bit about the industry and the knowledge, and have worked together on some different projects. We're working together now to see how we can help evolve this industry from, not only a technology perspective, but from a workflow perspective and other ideas. So it's been really awesome to work with Chris and his team. And, we're looking forward to continuing that.
Yeah, that's awesome.
I can probably jump in there too to talk a little bit about that. So it was funny because it was at the time when I was working between my master's and my PhD, and I kind of hit sort of the ceiling with where I was at in terms of, in the near future, I had done a lot, learned a lot, but was ready to sort of take the next leap. I was working primarily in the sector of construction, dealing with architectural cladding. And so at the time, really fascinating business. So we would scan new buildings before the cladding was fabricated. And we would, I'm sure that this is going to come across some of the work you've done, Matt. But what we would do is verify the actual locations of doors, windows, the kind of the levelness of certain features, how flat walls are. And there's this sort of big problem that if you assume that the construction site is built to the drawings, you're in for a whole world of trouble when you bring components that they're going to fit. And so what we would do is we would scan, and I say what we did, but the company's doing quite well, and they're still in this area. They scan buildings, they take that information, they go to the building information model, and they update critical features. And by updating those critical features, you can send the fabrication information for these architectural panels to a plant. And once they're once they're fabricated and sent to the site, they get installed, and 99.9% success rate. And so anyways, at the time I was working there, I was thinking, this is fantastic, but I kind of see in the near future that I'm going to kind of hit the ceiling. And so I need to find the next opportunity. Mm-hmm. And so I was sort of looking at my options. I was thinking, I don't really want to go back to school, but it's something I could do. And then there was this job posting for a position I think it's product owner. Brent, correct me if I'm wrong.
They change, right? Platform owner, product owner. Yeah.
Platform owner. And I was like, oh man, this would be great, because I've got this sort of background of research. I've got sort of big ideas, things I want to do. This would be fantastic. And I went through the process of filling out the application, and I was literally like just one mouse button click away from applying. And I was like, you know what? I'm just I think I'm kind of jumping on this too prematurely. I love everything about this. I think I'm going to see if I can get into a PhD program where maybe I can do that and some other things. And so it turns out I kind of started this process of talking to people at FARO. We hit it off really good. And through that, I was able to work with FARO and do my research. And the interesting thing is, at the time, it was sort of me competing with whoever was getting this job. But we found this amazing kind of ability to kind of structure the research I'm doing, the work that FARO continually puts out, and kind of where I'm going in the next phase of my career, which is working with a modular fabricator, to be able to integrate a lot of the technology that FARO is producing, and to really kind of see how it gets implemented on the ground level. So it's been quite the journey.
That's awesome. That's awesome. So
I know Josh is going to laugh about this when he listens to it.
Oh man. So where would you say, I think that's a good picture of kind of the overall focus. What's the immediate? So where are we at now as far as, one, Chris, your process within research and kind of wrapping up your schooling side, but even with like, the mix of both of you with the technology, what's the immediate problem that a lot of firms are trying to solve, or issues they have that this process is starting to attack? Whether it's the issues they know about, or again, even with most scanning and most new technologies, I think it's still at the point that people don't even know that this technology is ready to start solving problems. So what's kind of your guys' goals? Who and what type of issues are you attacking?
So right now, for me, what I'm seeing a lot of is when you think of a modular company, right? A lot of times you think of a fabricator. And what's been interesting to see is over the years, a lot of these companies are acquiring or partnering with architecture firms and possibly other subcontractors, and they're building this team into one organization, right? Mm-hmm. And what's interesting about that is, if you think of the way a current project is constructed through the traditional cycle, you have civil engineers involved, you have architects involved, you have structural engineers involved, you have the VDC techs, right? All these different people, and there's a workflow that works there, right? But when you go modular and you bring this design team in-house, it can help streamline the process. It can help you with avoiding the traditional obstacles that you see within a project, right? And you can make those design changes immediately, right? Because I can just walk across the room and maybe be able to talk to the architect who's in charge of designing this, or I can go across the building and speak to the structural engineer about an issue that we potentially see with, maybe it's lifting the box up off the truck or something like that, right? So it's been really interesting to see. I've been paying close attention to those companies as they start to acquire some of these organizations, or they partner up, right? There's still other companies who are still subbing that work out, and they create a more streamlined partnership. Another thing that I'm seeing an uptick in right now, particularly with wall paneling, is there's been this, I think, a huge growth. I don't know what the exact number might be, but just in my region and other account managers I talk to, there's a lot of subcontractors who are taking on the prefabrication of these wall panels off site. You see a lot of this new tech with the machines that can pretty much 3D print your steel stud, mm-hmm. and they're basically putting their Revit designs into these machines. They print it out, it's labeled, you can bundle it a certain way. Everybody's got their own workflow, but now I'm starting to see these general contractors take this on internally for not only their own projects, but smaller general contractors who can't make that investment are partnering up with these companies, and then they're building these panels out. And right there, for us from a technology perspective, that's a huge opportunity, because what you typically see, at least what I've seen from the prefab side, is you see a lot of technology used in QAUC practices on the job site, right? The as-built, the drone shots, the total station measurements, but you don't see a huge QAUC application on the inside generally from the construction perspective, because there's a little bit of slop, a little bit more slop in construction than you would see in manufacturing, right? We're working with eighth quarter half-inch tolerances, where in automotive industry and aerospace, we're dealing with millimeter. But we're able to take that technology that we use in those industries and try to apply it to this. And I've really been having some interesting conversations with my current customers who are entering that phase, because it creates a conversation piece. Well, you're laser scanning your job site for floor flatness, as-built, etc. What are you doing on your manufacturing side? Why aren't you applying the same principles? And I think Chris mentioned it earlier. You can apply these technologies in there and be able to take a scan or project a template and see if something's off, right? And you find those errors in the process before it hits the truck. And that way, okay, that wall panel, it's all said and done. It's got, maybe it's got a little twist in it. I can either fix that before it goes out and becomes a problem, or as it's being delivered to the site, I can tell the super, hey, panel A4 has this issue. Just know that before you fit it up.
Yeah.
And now you don't have the implications of having to do clash detection and having those issues. Yeah. And that's where I'm seeing, our technology use case grow in this prefabrication arena, is especially with existing customers who have this technology already and are going to that route. It's a really, really fun conversation to have with them.
Yeah. So what, what percentage or how widely adopted is this process as far as, prefabricating modular pieces to bring in and construct? I mean, is it, what percentage of projects are starting to actually integrate that, you think?
5% is.
Go ahead. Yeah, I was going to say 5%. Yeah, I can't remember the report, but there's several reports that's published.
It is very low.
Yeah,
so,
it's low.
And what do you think why is it so low right now? Is it just because of how new it is? Is it the lack of knowledge? Is it the lack of, firms out there that can provide it? What's going to cause that to grow?
Should I jump in on this, Brent?
Go ahead. Yeah.
Okay. I think it's important to think about what modular, if we're talking about modular specifically, what kind of typologies of buildings or assets can we actually build? Mm-hmm. Not every project is conducive to go modular, for instance. I think there's actually a greater opportunity for prefabrication. And again, we can probably get into sort of the semantics of prefabrication versus modular. It might be helpful to actually distinguish between that, because they're often used interchangeably. And they're quite different from a typological standpoint. So prefabrication is simply the act of just taking something and rather than making it on the construction site, doing it in a facility off-site and bringing it to the job site. So prefabricating it. Sometimes off-site construction, off-site manufacturing is used kind of interchangeably. Modular is different. The idea with modular is you take and try to incorporate as much repetition in your product as possible, and to try to have repeatable assemblies. And we can talk about buildings, for instance. Often when we say modular buildings, we're talking about volumetric modular construction. So a three-dimensional space that is enclosed. And you can think of it kind of like Lego blocks. If you're going to build kind of something out of Lego blocks, you've got sort of these, most of the times it's rectangular prism that you're bringing to a site.
I think most people picture the C-train type,
right? Like your seat can or your shipping container.
Yep.
And it's often a good way to tell people, that's kind of what modular is. But it's funny because when you're in the modular industry, we always say that that's the worst form of modular construction there is. You're taking something that was purpose built for transporting cargo and you're trying to adapt it into the built environment. And it's funny because, for many times people say, oh, we have so many of these shipping containers out there, it's more cost effective or it's cheaper. But there's actually new companies coming out that are developing kit of part modular systems that are cheaper and actually better from a built environment perspective than trying to adapt these shipping containers. So going back again to that 5% number, I think because of kind of the way that you go about doing modular construction, it doesn't work for every single project. One of the biggest fallacies that you can do is to take a building, a design that was supposed to be done in situ and convert it to modular last minute. I have seen time and time again how that just ends up being just an absolute nightmare, because you have to go about a modular project in a very, very different way. It requires digitally building it before you actually physically.
Yeah, it's just like, just like we're talking about with the technologies, right? There's a lot of different scanning types of equipment that are different, they're all different tools used for different, reasons, and some are better at things than others. Same with modular, it's like you're saying, you can't just take modular and apply it to any project. There's certain scenarios it's best for, right?
Yeah.
So what are some of the main areas we see modular growing, or if it's not already, where would that percentage actually grow?
Right now, the main drivers are in, multifamily living systems, hospitality, hotels is a really growing one right now. Even with the healthcare networks, right? We saw earlier this spring with when COVID really started having a large impact across the world, globally, we were seeing it was the first time I saw modular sort of like getting its spotlight, and unfortunate times, but getting that spotlight. I believe it was in China. They built a modular health hospital in 7 days using that. And modular, Chris says volumetric. Modular can go beyond just being a steel box that people would think of, right? It could be, like I was saying earlier, it could be a medical pod, right? It doesn't have to be tubular steel, but it can be so much more than that. But I think it started to really gain its ground there. So I know, Chris, and up in your guys' region, we're seeing it a lot with like around the universities and stuff for residential housing, student housing. There's a lot of areas in larger cities like Chicago, New York, out on the West Coast to try and help with bring more affordable living. Now you can argue what the amount of affordability is with that, but these are some of the areas where modular is being looked at, and I think going back to the 5% number, I think one of the other things that probably has kept that sort of lower, especially from a modular perspective, is there is an investment up front, right? You can't just be a general contractor or an engineering company say, I'm going to build modules tomorrow. There's a process to that, right? What kind of modules are you building? Structural steel, steel studded walls? Are you doing wood, right? Okay. Where are you getting your steel from? Are you going to print your own studs? Are you going to sign a contract with a local lumber company? Then you have to hire staff. You have to hire, you have to purchase tooling. You have to purchase all the equipment, the technology. So it's, you're talking, millions of dollars to do an investment like that. And I think this is where FARO and other companies who are leading in this industry can step in to help create a process to streamline that for these clients that want to take this step, knowing the risk, but try to take a smaller risk and get help from these industry experts who have this, this breadth of knowledge, and help them know that, okay, we're making the investment. We're going to be able to get up and off the ground running as soon as, we sign the contract, right? And we'll be able to produce these units without any, hiccups, logistics issues, things like that, right? And there's a breadth of other, Chris may want to mention some, but that's one of the big ones I see there is that initial investment, right?
Yeah. And kind of piggybacking off of that, a good way to think of it is, let's say you've got a conventional build versus a modular build. And in modular, you've got this high degree of repetition. Ideally, the more repetition, it gets into this argument of like, do we standardize our product or our process? I'm a firm believer in standardizing your process because it allows you to customize. But if we compare a conventional to a modular build, if you encounter a design error in a conventional build, typically the impact is not going to be as significant as if you encounter a design error in modular, because it's not just one problem, it's 100 problems because you've got 100 modules. And so, exactly. And so there is very important, and this is kind of, unfortunately, we've seen a lot of attention and it's become sort of a trend to go modular, to go prefab. It has to be done correctly. As I was alluding to earlier, you have to digitally build it before you physically build it.
So you picture the Legos, right? So you're like, if your Legos, all the whole, all the little pieces or the holes are just the wrong size, you can't build your.
Yeah,
exactly. And so there's a lot of risk in modular. And I think really what laser scanning specifically allows us to do is to minimize some of that risk. Mm-hmm. So as we're building modules, we can go off of faith that our expert fabricators are doing the job correctly. Yeah. I can tell you from experience, if we're talking about structural steel modular, welding distortion is very, very tricky. And talking from an academic standpoint, we're not even on the tip of the iceberg to try to figure out and simulate how the effects of welding distortion can affect geometry. But let's say that as we're building it, we scan it. Now, all of a sudden, we've got this digital artifact that we can virtually fit together. Yeah. So going back to the Lego analogy, it's like playing Minecraft before you play Lego. We're doing things in a digital world. Yeah. And if we can get as much in that digital kind of ecosystem, it allows us to predict and resolve things before they become $1 million liabilities.
Yeah. Yeah. And I've seen the main application I've seen for prefab really started in the industrial side for oil and gas facilities. And even there, it's like, before using 3D models to design this new tank that's going to get put in a facility, they're going off of drawings and stuff. And yes, the fabrication shops are experienced and they're good, but unless you're checking it, I mean, we've had scenarios that once we actually started doing that process for, they designed based on the scans from the facility, then they built the vessel, then we scanned it, did the comparison. It's like they installed the nozzle on the opposite side of the vessel on accident. There's now again, a quick check of that with a scan will save them $3 million because they didn't assume it was fabricated properly, shut down the facility, go to install it. And then, oh crap, like our nozzle's not at the pipe. We have to leave everything shut down, so the benefits out of that upfront verification for a lot of industries far exceeds the potential risk of not doing it. But at the same time, that's also sometimes still a hard sell point in some industries, at least, right? How do you convince the upfront expense that they aren't used to in telling them they will have potential saving,
I've got a good story.
That is a difficult battle that, from a sales side that we have with these organizations where you want to introduce this sort of QAUC, right? Oh, we've been doing this for 30 years. Our stuff's good, right? We know it's good. But, being able to catch those errors and not have to deal with them later on is a tremendous value, right? That's an easy proposition to sell a scanner on. But I think it alludes back to Chris's point where we talk about hardware versus processes and what we focus on. And hardware will continue to get better. But we're at a point where I agree with you, Matt. I think it's very stable. I don't think we need to go much more accurate than it is now and things like that, right? But I think where we have to focus on when we're trying to talk to these organizations about adding this process in is how do we streamline it, right? How do we add a scanner into that process and not interrupt the current workflow and be able to check that and provide valuable feedback, and also at the same time not sort of demotivate or talk down on the fabricator's work, like, oh, you read the print wrong. Well, that can happen, right? You're looking at an object that's symmetrical. Any one of us could make that mistake, right? So I think that there needs to be definitely a focus on the process and focusing a value proposition for that process for that organization to get them to sort of jump into that, right? We see that with the laser projector, with the tracer. You go into an old school fab shop, right? They're building handrail systems and structural steel. And the way they get it is they get a set of prints from a detailer. Maybe the detailer works for them, maybe they don't. And it takes them X number of minutes to plot it out. And they got a tape measure out, they chalk it out, and they're like, we're good with this workflow. We don't want to do anything else. And what we've seen through that with different companies we've talked to is you're always going to have that, right? And what we tend to see is you find that champion, right? That technology champion. Maybe it's the CAD guru. Maybe it's a guy who's a fabricator, a little bit younger, but knows computers and things like that. And generally we help them help their guys sort of absorb this technology and work with it. And then once they make the switch, like, man, how do we do it before?
Well, I think it's going to continue to get easier to adopt the technology as those younger people, like you're saying, are actually coming into those roles.
Yep.
And it would be most beneficial that it happens while the experienced older guys don't retire yet. And you get you get the merge of the young guys with the new tech and the old guys with all the knowledge to mix, and you have these great processes. But either way, I think that over time, it is going to get easier to adopt, because you do have these younger guys coming in that are getting out of school with virtual reality, and they've been playing video games, on their off hours. And so
but you have to understand the background of it, right? Just like, when I went to school for civil engineering, Autodesk has a stormwater tool that can run the analysis and all this stuff, but you still have to understand that process behind it, right?
Yeah.
That's the old school mentality. So we have to carry that same thought, whether it's I go to do an undergrad program or I go to one of the trade schools. I'm learning from those guys who have that experience.
Yep.
And then it's just a matter of trying to figure out how to hold their hand and
one thing
through that process.
I kind of think right now, and then Chris, I want to go back to you. You said you had a story, so we don't want to miss that. But one thing that it does kind of make me think, though, is, we often get into these conversations about like our current education system, and like sometimes we feel like we're teaching kids things that they're wasting time on, and we should be like updating what we're studying on ages based on like where we are as a society and where we are with technology. And so it kind of makes me think about math, right? Like, let's teach enough that you understand it by hand, but do you have to be able to do every single type of thing by hand when I've got a computer with a calculator, a phone with a calculator? Like, if I know how to do the problems, let's start to utilize the technology to do the things that it's really good at, which gives us more time to focus on future things rather than like, here's 8 years of like how they used to do things. Oh, and here's a calculator. Okay, go get your job. Let's spend 8 years like, here's how to use the calculator. Let's start designing new programs. Let's figure out even better. Like we need to catch up on that. Yeah. And I think it kind of lays over even into technology and into construction industries and engineering and everything. Is we need to get caught up with the technology that even exists now. Like, who cares about what scanner's coming out in the future? Like 10% of people even use what's existed for the last 10 years.
Right. Okay. Yeah, I couldn't disagree with you there.
All right, back to Chris's story.
I was going to say, just going back to talking about kind of that, it's really centered on education and understanding. So I was working during my master's with a modular fabricator, and it was a time where I was myself, it was like being introduced to the world of scanning. And so here was this, student who came in sort of awkwardly on the sidelines with this like piece of equipment that, by no fault of FARO, it didn't work at all. But that was because it was 10 years old and it was on its last legs, and it was abused by other grad students. That's kind of going to be the story I go with. But I had all sorts of contraptions just to get this thing working, and I was, in and out every day, just scanning everything. I had no clue what I was doing, but I just went about this journey of just, if I scan everything, I can take some time after and learn. And slowly, as I started analyzing the data, I would find things. I'd be like, oh, well, this is interesting. I see. And at that time, I wasn't really engaging the fabricators. I wanted to kind of keep my distance, but I was given access to the facility, and I would find things that I would be like, hey, that's going to solve this problem. And so I managed to arrange a meeting with the higher ups and the important people. And here I am kind of shaking nervously. And I showed them a scan of something and said, yeah, this problem you have when you bring your modules off the line and it sits on the floor, your floor is not flat. And it's so funny. I'm sure all of us on the call get this. People think floors are flat, and that's the furthest thing from the truth. There's so much variability in floors. And so of course the modules kind of warped to the geometry of the floor. And I showed kind of a projected view of one of the scans, and I said, yeah, it deflects in the middle by about 30 millimeters. And they laughed at me.
Yeah.
And I said, well, go take a string, pull it to one side and the other. And I thought, okay, if this goes completely wrong, I am canceling my degree. I'm just going to go, I'm going to try to find a job in a completely different career. But to my amazement, and thankfully it worked out this way, they took a string and they measured, sure enough, the deflection was about 30 millimeters. And it was just at that moment that they kind of viewed this technology as not being this like futuristic thing that's going to waste their time, but it could have some value.
It's the construction wizard.
Yes, exactly. and within 5 years, that was about 5 years ago, to where just last year I was doing my PhD and I got in touch with another modular fabricator, and I had the ability to take my spool scanner and do some scanning, just some preliminary stuff. And I showed them the technology. And before I even showed them the results, they were all like, oh, we need to get this. I need you to put me in touch with whoever can get me this technology. And what I saw was a significant jump within 5 years of just this mindset of, we don't want to take on additional capital expenses. We have enough on our plate just trying to do modular. But I think it's really this huge paradigm shift that we've seen in the industry, to where if you're going to do something innovative, you have to do it right. And all of a sudden, technology is not this like R&D budget of 2%. And if we get it, great. If not, then, we'll just have to figure it out and solve it on the field. Like everyone is, I think, who's doing it correctly. I think people are understanding, no, like we need to make sure that we're doing the investments, establishing the processes and doing it right, because the consequences are really dire if things go wrong.
Yeah. And we see that honestly a lot. We have for the last 10 years of also the lack of education on the different technologies and how people select, what scanner do I buy? What software do I use? What is it really going to take to integrate this and use it in a process? Even just the lack of education there, of people end up buying the wrong tool because it was cheaper, and then they use it in a process where they wanted the highest level of accuracy. And they, people see, I'm doing a webinar tomorrow on the iPhone LiDAR. People see the newest, cheapest thing come out, and I've literally have seen people say, we can just do our own scanning now.
Yep. I'm just waiting for it. I will be watching that, but I'm just waiting to see what happens there.
And honestly, that's why we're on this podcast. Like my goal, I've seen this so much as a service provider who goes out and scans for people, and we get hired because somebody scanned a job and did something wrong, or they didn't register it, or they didn't control it properly, or they didn't scan. I mean, it's kind of all over the place. Or they used a photogrammetry tool for a high precision job that wasn't good enough for the accuracy need. And so we're trying to continue pushing that education of, okay, there's 100 tools out there, but you have to know specifically to your project need, your client need, your industry need, your data, what software is it getting like there's so many pieces to the puzzle. That education is a piece that's been lacking for quite a while.
And you have to do it right. That's the thing. There's nothing worse than saying, okay, you know what, financially we can make this $50,000 investment, and then get the information. And if that information is wrong, it's worse than not using the technology at all. Like, that's the problem. And I think that's where there needs to be education going with the technology. So, I mean, podcasts like this are extremely important. And I think it's really relies on us as practitioners of this technology to provide that education, because there's nothing worse than getting the absolute wrong information, and then it just completely screws over.
I think on the education topic too, I think it's interesting to see there's so many different undergrad programs, right, that offer surveying and this and that. And one of the things as I've worked with different universities that I've wanted to see is, with some of the trade groups, like the local 597 here in Chicago, they created a quick program for their pipe fitters to engage in 3D scanning, right, with Revit and everything, and the laser scanner. But going back to the whole topic of continuing this education, what I think, whether we're talking about scanners, drones, or laser projectors, or whatever the case may be, I'd love to see the universities adopt a sort of generic or universal course, and think of it as, if you're in your undergrad, it's a year 3, year 4 course, and it's a course where you have labs where you can engage in these different technologies. of how to use them. What's their purpose? Maybe you spend 8 weeks on laser scanning, right? Whether it's a FARO, it's a Leica, or it's a BLK, it doesn't really matter, because we're learning about that technology. But the same thing applies to, from the manufacturing side, and learning those integrated technologies from a laser tracker to a portable CMMR. And I think it's one of those things that needs to evolve and change in the education sector. And hopefully things like this and conversations with those universities, there's been a lot of different things that have happened over the years with laser scanning, as you've seen, specifically with concrete, right? There's specific groups being formed. So I hope that it continues to evolve. It needs to evolve. Because like you guys said, it's hard for these folks to keep up and know what the right product is for them. And we don't want to see those architects all going out and buying iPhone 12s and mistakenly doing those scans where it may or may not be the right fit for what they're doing, right? So
Yep. Well, and if the universities don't adopt it, we'll just open the Reality Capture Network University and take
Sign me up.
The new Autodesk version.
Sign me up. One of the things I wanted to talk about, sort of talking back on logistics and things like that, is with every different area you build, there's different codes and inspections and things that need to happen. And I really never thought about it until I visited a local client, and they brought it up to me, the idea of inspecting these modules and virtually, right? So there's a well-known story about the hotel being built in New York. I forget, I think it's like 80 stories or something like that for Marriott. And what's interesting about that project is none of the modules are being built in Canada or United States. And you go, well, how is that economical to build? They're actually building them in Poland, and they come over on a ship, and then they get craned, they get put on a truck, and then they get craned over. And we see the similar instances here in the United States where, maybe we're building modules in Canada and in one territory, and we're shipping them to another territory. Or here in the United States, we're building in Chicago, and we're shipping them to the east or the west coast. And I laughed at that, because the client I was talking to, I was like, how's that economical for you guys to build a box here and put it on a truck and pay a trucker to drive 3 days across the country and put it on a building there? And when you crunch the numbers and you talk about having a factory there and right, it starts to make sense. But then there's the other side of it. There's the labor side, and then there's the inspection side, right? Well, how do you inspect a building that's being built here and being built up over there? Well, laser scanning, right? Virtually, do a virtual inspection of your pod or your module, right? These are systems that you can immerse yourself into over the web, like using WebShare Cloud or some other platform. And that inspector can go in there and count the number of screws that are in the wall, right? Or measure the deviation in the floor if that's something that needs to be inspected. And it's mind blowing, but it's such a simple idea.
Yeah.
And it loops back to the whole conversations of, okay, you have a general contractor who does scanning on the job site every day for their own QAQC. Then they start up this prefab or modular construction division, and then you don't see them using that technology, but they have it over here. So it creates a really nice conversation piece with them, and then it opens up this challenge that they have and a way to work through that challenge, right?
Yeah.
So it's always interesting to talk about the inspection side of it. And Chris, I don't know what you've ran into there with it, but I know here, like for instance in Chicago, there's several different inspections that have to be done on these buildings throughout their life cycle. And this is another way for them, even in this COVID era, right? Even if it's local, I now don't really have to have somebody come into my building and potentially expose somebody when they could do it at home in their PJs from their computer desk, right?
Yeah. Yeah, we're trying to help solve a piece to that puzzle as well that we see, even without talking about fabrication, just talking about, clients that have either multi-site projects through different states or clients that are on the East Coast that have a project on the West Coast. And there's still that relationship gap of, hey, I've only ever met one service provider who owns a laser scanner, and I think they invented the technology and they're the only people who exist. And I literally, that's not even a joke. I've had people ask me those questions like,
I believe
so
it.
do other people own these scanners? And I'm like, no, like, yes, like this is all, I didn't make this. So we see that need for a lot of industries because there's a lot of clients out there who have thousands of places, thousands of projects all over different states and countries. And instead of, staying on the small picture of, hey, I'm going to keep all those projects to myself at Nexus and we're going to scan everything and we're going to travel the whole world. I'm like, okay, we want to educate people. And then we also want to build part of what the next step in our reality capture network is, not just a podcast and education, but actually building out a network of all of the professionals in this industry so that when someone says, oh shoot, my building in New York needs this quick scan done, they don't have to send the guy from California that is going to fly there and it's going to take 4 days for me to get there and stay and scan and fly back. And it's thousands of dollars of travel. Instead, we want to start building out this community so we can partner with those people and say, hey, we have people in every single state. So when you're ready for that quick scan, we can now make it more affordable for people to adopt it wider, because now instead of being $8,000 to scan that little site, it's going to be 2 or 3 because we already have someone there. So we're trying to solve that gap as well, because I think that's another reason that the technology is kind of still held down is there's a lot of those applications people would probably use, but they have to just start Googling, like, can I find a laser scanner in this state? And then they don't know the firm and they don't understand the technology enough to ask for what equipment they have. And, there's all these pieces that a lot of clients don't understand. They don't even know where to start.
Yeah. No, so definitely agree.
I was going to say, here's tying it back to the modular thing. So what you were describing, Matt, was talking about like a decentralized kind of service providing role. And I think an interesting thing has kind of emerged during COVID in the modular industry, specifically in the US, which there's sort of 2 emerging types of organization from a supply chain standpoint. There's vertically integrated, which Brent was talking about earlier, where you bring in all of the parties and stakeholders into one entity, and that allows you to gain a lot of efficiencies. The problem with that is it stifles innovation if there's just a couple of big players, and then they just keep buying out all the little guys, and they just, they basically have a monopoly on the market. So they don't have any need to keep innovating. The other side is a decentralized kind of supply chain approach, where you've got these sort of networks of different modular providers that are able to build off of a standard template. And we've seen a quick little shout out to the Modular Mobilization Coalition. What they've done is they've taken all of these modular factories across the US and they've brought them into this network. So that way, when there's a project that comes up in Seattle, they have someone who's close by who can make modules to go to a building there. And, maybe on the East Coast, there could be a project somewhere else. And so having the ability to, similar to how you're building up this network, I think we're seeing this in the modular industry. And I think that's something that's really powerful. And again, it goes back to actually tying into the whole laser scanning piece, because there needs to be standardization of processes. Can you imagine just having one design template that you send to a factory, and if they're using the technology properly, but the other people aren't in this factory, the whole network's going to fall apart.
Yeah.
Oh,
that's where technology.
You hit the nail right on the head there, Chris. We've seen that, right? Where you have factories building literally the same product and getting differences in product quality because of the overall process, right? Yeah. Whether it's built in Mexico or Canada or somewhere else around the world, if the steel's coming from the same company and the design's coming from the same company, but your process is different, you're going to see different results. And you see that with laser scanning. You see it with traditional layout. You see it with anything you do, right? it's not this new idea. It's applied all over the place.
Yeah.
You know, it's a practice.
One of the studies we recently did, this is sort of a shameless plug for some of the research we were doing. We had the ability to look at a modular building that was going to be kind of mass produced, multiple of these buildings. And, you know, there's a big question as to how do you specify tolerances in modular construction? Because, you know, I can go off of guidelines and codes and standards, but there's nothing out there right now that's modular specific. And even if you had modular specific tolerances, it can vary between different companies. And so what we did is we had the ability to basically scan a whole project as they're putting components together, making sub-assemblies and full assemblies. And we were able to track the geometry, where things were distorted, and be able to create this sort of roadmap in the first project. And in the second project, we were able to take all the lessons learned and be able to streamline that. And so, as Brent was saying, you know, having two factories producing, you know, in theory, the same product, but in reality, it turns out to be different. You even sometimes have this within one factory if you have variability within your process. And so not only, you know, I think this is maybe a piece that in addition to the use of scanning, there is a need to have things like fixture technology. And I guess, Brent, feel free to jump in and talk about this. But in addition to just having technology that can capture what you're building, there's a need to build up fixturing systems in order to ensure that you can have a repeatable product coming through even just the same factory.
Yeah, no, absolutely. We partnered with a company called Blueco here locally in Chicago. They're out of Naperville, and they're a distributor for a German company that builds fixturing, and that we got introduced to them through Skender when Skender built up their modular construction facility here in Chicago. And it allowed me to see over this last year and a half or two, you know, going back to these differences in fixturing, right? When you look at the number of general contractors who are prefabricating wall panels, I've seen several, and all of them have different fixturing. And while wall panels don't have to carry the same degree of accuracy or tolerance that we see in volumetric construction, volumetric modular construction, there still needs to be consistency there, right? You still want to have a product that's consistent. And I think it's important that these tools, these fixtures are sort of repeatable and have this consistency. That's one of the reasons we love working with Blueco, is we cross paths with several different clients that Chris has worked with us on, and others that we've worked on. And it helps sort of carry that process over, right? It's not just about the hardware, right? It could be about the tooling, it can be about the software, it could be about the automation. But it's that one piece of the puzzle as well that helps this process be more streamlined and more within tolerance of where it needs to be. And I think when you look at fixturing, people sort of see it as that's one of the things that they can build themselves or sort of go the cheaper route with. And I think it's one of the more important tools, because it literally is the spine or the backbone of what you're building, right? So whether it's built with, you know, a unistrut or angle iron, or you're going with a high-end table like what Blueco would put out, it's important that those fixtures are built solid, because at the end of the day, you're building everything off of that, right? Whether you're using a scanner to tell you where things are out, or you're using a laser projector to template things out, you know, those things are only going to show you or tell you. But not having those tools, the right tools, or the tools that are you know, within building a solid frame for you to build off of, it can throw everything off down the line. So I think, yeah, fixturing, it's an extremely important piece of the puzzle, and it's part of that process, and it will continue to be important as we continue to develop this industry further. And not always do you see fixturing as you know, one company may have fixturing for the large portion of what they're building. Another may have something more automated, and they use the fixturing for some smaller things or more customized things. But at the end of the day, it's still part of that process in both prefabrication and modular construction. Great point, Chris.
Awesome. We talked a little bit about, Chris, some of your past research. You want to maybe touch on that a little bit? So I know we talked about automated updating from scan data of models.
Yeah. Yeah. So that's actually some of the stuff we're currently doing. I did talk about some of the previous stuff, which was, previously we took laser scanning as this ability to establish benchmarks. So if we have the same product moving through a manufacturing line that, if we're using fixtures or, assuming that the way we're building doesn't change too much and the product remains the same, we can use laser scanning in our first project as sort of a pilot in order to get a rough sense of where we need to make those fixes to continuously improve and to hit the marks we need to make sure that at the end of the day, that things go together properly. It's kind of moving into sort of where the future. I've always been fascinated with BIM. I think that there's so much that goes into that technology that we're not using it to the full abilities of what it boasts. And so one of the key features to and when I say BIM, just maybe for some of the listeners or viewers who aren't familiar, I mean building information modeling. And I think it's something specific to the construction industry. Often it's sort of seen as being synonymous to 3D modeling. But there's really a second or additional layer to, it's not just the 3D model. There's additional semantic information that gets assigned and associated within this so that it's much more powerful than just the raw 3D geometry. And we use parameters as a way to capitalize on efficiency. So if we can have parameters that we can easily adjust, it gives us the ability to be able to reuse these models from time to time. Maybe in this case, we want to have parameters for the geometry be tailored to this situation. And if we have these rules that we embed into a BIM, it allows us to service a range of applications with sort of one design code or rule or language, if you will. And one of the really fascinating things that we just wrapped up doing a study on was, what if we were to take geometry and rather than kind of hard coding in what it looks like, what if we were to assign parameters? So let's say a simple box, we've got the width, the length, the height, and rather than kind of hard coding in what those dimensions are, what if we allow those to be kind of sliders? And then what if we used the raw data we got from scanning to update that? And so we've used artificial intelligence and specifically genetic algorithm in order to figure out what those parameters are to best match a point cloud. Now you might be here kind of scratching your head thinking, what's the point of all of this? So often we have distinct levels of development when we develop a BIM. We start with a high level architectural massing. We often call that kind of an LOD or a level of detail or level of development 100. And this level of detail gets finer and finer until we arrive at a level of detail, often like a level 400, which is the details in this model are such that a fabricator can take it and directly build something off of it. It's got the bolts, the nuts, and everything I need to know how to actually build it. It's not just sort of this block massing that looks like, oh, it looks like a building, but it's not resolved to any level of detail that I know what product I'm actually going to build.
Yeah.
And there's often a gap from design. We often have a lot of effort going into our BIM, but what we actually build typically doesn't match things in the design perfectly. And so there's often workflows where we have to recreate a BIM. Often it's called scan to BIM when we use laser scanning technology. And there's so much research in sort of the academic world on how do we automate that? How do we just take a laser scan and automatically produce a BIM from that? And I looked at this opportunity that, we're putting all of this effort into making BIMs. Why are we going through the process of recreating it when we can start investing in technologies that simply update parameters? So we've got this great working model that all we have to do is just give it some information from what we actually build, and it will figure out and adjust those parameters so that we can get that kind of final as-built BIM in a much more effective way. And so we just, as I mentioned, we just wrapped up a very interesting kind of case study. And I think that we're going to continue to kind of see, hopefully, research kind of support this. So it's not just this painstaking process of taking a laser scan or a 3D point cloud and have to infer, what's what. I'm sure you come across that all the time, Matt, in your work.
Yeah. I mean, that's a big part of our business is just we see the same issues across all industries, industrial, architectural, forensics, just everything, where they just need existing accurate information. And man, even just back to the basic conversation earlier, touching points on like, some people think that everything is 90 degrees. I have had people argue with me that had 20 years in architectural design experience that told me there is no way this model you gave me that has beams that are not on a perfect grid are actually like that in the field, because we design it down to this tiny degree and the surveyors lay it out perfectly. And I'm like, I came from surveying. I absolutely promise you it is not to that tolerance. And then it gets constructed and it's even off more. Like, there are people that think everything is perfect 90-degree angle. And then you go back and you're like, okay, before scanning, there's really no accurate as-builts then. Like, right? I mean, every existing as-built documentation drawing was the design drawing, right? And then it was maybe there's some field verification that happens.
Tape measures.
But nobody's taking that design drawing and like angling things all weird and telling, so really there is zero accurate as-built information that exists. And we've run into the scenario with clients that started to adopt having us come out and scan. And they did it because there was no as-builts, but they really liked the data and the use case was there. So they then did it on a project where they're like, okay, well, this building, we actually do have the old as-builts, but let's do this and scan it and then do a comparison. And it's like, they thought they had good as-builts, but you're still seeing that if you scan it, you're always going to come up with something different than what your existing as-builts are. And depending on the type of project, this specific project was an industrial warehouse. They were prefabricating steel, big steel columns. And they were like, if we would have moved forward on this one with the existing as-builts that everyone thought were accurate, we would have prefabricated this steel. We would have run into that scenario during construction of crap. It's not going to fit. These really critical areas are going to be off by a foot. Our drive aisles are going to be smaller. Like, it can't work. It's going to be, hundreds of thousands of dollars of waste and delays and all this stuff. So again, we see the technology all over the place in every industry. So it's really exciting to dig deep into like these specific topics, and still know that it's like, there's this much to dig into in every single industry, like anybody who's building anything.
It makes the cost of a scanner or service provider coming out very minuscule when you look at something like that. As simple as one beam in a building where you have a conflict, that could be as much as $10,000. It could be the meaning between an hour or two to fix to a couple days, right? And all that costs time and money, because now it becomes okay, I got to have another laborer out, I got to have another carpenter out, right? So it all adds up, and I think people get the idea of it, but I think it comes back to again, said it earlier, education, understanding the need, right? I have clients that I talk to and they're like, well, we got to scan the whole facility. We're designing a chute or something to go through it. And okay, that's fine. Well, we got to model all this. And my first thing is, well, are you tying into it? Are you tying to the structure? Or are you tying into that piping system? Well, no. Okay. Well, then you don't need to model it. Save the time for your client, understand what your needs are, and then design your chute, and then that's why we have clash detection and all these different processes for laser scanning.
And we've talked about these on some other discussions and stuff too, of again, the education. Like, there's times that you don't need to take the scans and model them, right? And sometimes that's the best option depending on what you're doing, because even within doing scan to BIM models, which again, that's a big part of what we do as well, even that is not cookie cutter. Like, it's very specific to the job and the client and what they want and how they want it, because, okay, well, the scan data is the beams are angled a little bit. Okay, well, the structural guy wants to know exactly where those are because he's fabricating that it goes from here to this beam, but the architect wants things 90-degree and best fit because Revit isn't going to operate properly, so there's even within just creating the model, you can do it 3 different ways depending on who's using it and what they're using it for and what the accuracy and yet if you use the point cloud directly and you're measuring it in individual locations, then you have the exact dimensions of what you need to build. So sometimes the scan data is the way to go. And again, this still comes down to the education, because ultimately, if the client has no idea about this whole discussion we're having, if they just know, okay, well, these guys say they can like scan it, model it, fabrication is going to be perfect. People go in there not understanding all this and they don't request it a specific way. And that's where things go wrong. And then they don't trust the technology and then the data come out, so the education and I keep saying just the communication, very beginning of jobs. We've even worked on jobs in the past. We know what we're doing. We've still seen projects not go proper because our client who was requesting data didn't talk with the other trades about, do we want it angled or do we want it 90-degree? So even just overall team communications on construction jobs, understanding, look, if you're implementing this technology, let's get everyone on board so we know what file types who can use and who's in what software. And, I think communication is like just an overall area that needs to be improved. But Chris, back to even just the automated updating of the models, that is an area that for future, as that becomes doable. I mean, it's going to make things so much more. It'd be a lot easier to take something where you already have the design model and do those updates and actually call it a final as-built and keep that on hand for future. I think that would be awesome.
And where I kind of first saw this was going back to when I was working in industry as a computational design specialist. It's an interesting kind of phenomenon that happens with stick-built buildings specifically. You've got the steel or whatever structure goes up. You've got the floors, the walls, the doors, the windows, and it's the last trade on site that has to inherit all of the problems that are created by all of the other preceding stakeholders. Yeah. And it's like, okay, fine. We were using scanning and we saved our clients so much money because by scanning it, you've got this immediate ground truth. You can update things. So rather than, the status quo of every architectural cladding company out there spends X amount of time because half of it is just on rework, cutting things. Yeah. We can take that, and although it takes like a week to scan massive projects, we can then turn around another week and things, overall we're saving the client lots of money.
Oh yeah.
I think what I kept seeing this time and time again, I said, well, why can't we build buildings properly from the get-go? Yeah. Okay, that's kind of the first thing. But if we can't, can we build an intelligent model that as we're building, we can kind of, okay, we'll do a quick scan now that the steel's gone up. Where have things shifted and moved? Okay, now let's hit the button, let's update our model. And then things can kind of progress through the project so that at the end of the day, it's not saving the architectural cladding stakeholder money, it's saving the client money. Yeah. It's now getting buildings built that are actually on budget. Since, like, have you ever heard of a project that gets built on budget?
No.
I still
very rarely.
And this is important because we're facing, crazy amounts of affordability in the market.
And I was going to say that earlier when you were talking, Brent, I didn't jump in and say it, but when you were saying that, some of the guys that are slow to adopt and they're like, we've been doing it this way for 30 years. I was going to say, well, that's why the construction industry is known to have trillions of dollars of waste every year. It doesn't mean it's the right way.
They'll admit they've had very few issues, very little scrap and waste. And I've visited customers where they show me their waste pile and I remember going to one customer and we showed the projection technology and, we explained everything it could do. And I remember walking out and putting it in the box and the guy I was with goes, see, they could have used the projector on that rail. The rail was bent. It was a finished rail. but it was all bent. It wasn't perfectly straight. And part of it's probably because of the welding process or something else, right?
Yeah.
And you know, it's little things like that, right?
Yeah.
That you see. But I think, you know, on this topic of automation and efficiency, where I think, you know, on the idea of laser scanning, it's not done enough throughout the project life cycle, right?
Yeah.
You see it done with, you know, certain contractors doing concrete work, others who are doing as-built for the building before they start the project, but you don't see it through the life cycle of the project, right? And whether it's a cost issue, it's a time issue, right? Because we see these, like with vertical high-rises, the pour cycles of these jobs is just insane how tight they are. I mean, down to like 3 days, and you're like, well, the concrete, is it even cured yet? You know, and it is, of course, right? But you start to think about the processes and how can you do that scanning, but be more productive, right? And then things like Spot come into play, and automated drone flights and automated data upload to the cloud. And this is where I think construction's going. And this is where I think construction, our clients, those folks who are in this today, this is what they need to look at, because people see scanning as it's a cost to the project. And while that's true, I like to say, well, think of it, this is just a tool you bought to enhance the productivity of your project and make sure things are going into place, you're avoiding issues, and then you sell them on that. But then now you have this data. What do I do with all this data? And now I got to have a person to analyze it. So as we continue seeing this evolve over the next couple of years, we're going to see more automated approaches, right? Being able to upload scan data more directly and have more efficient processes like in Build It and these other programs, right? And we'll see the same thing in manufacturing and with prefabrication, right? You know, one thing we've worked on is, you know, I can take a Revit file and I can open Build It and directly import that, and I can write a script to automate the template creation process, right? And basically telling the projector that I want to project this piece, and this piece, versus having somebody manually click there and put this and this in place. So we'll see more of that as we go in both stick-built construction and modular construction and prefabrication. But it's one of those things that you say autonomy. It's a huge challenge we have today. And it's one of the biggest, I think, topics right now that people talk about, because there's so many advantages to it, but there's still a lot of unknowns about it as well.
Yeah.
Here's sort of my, sorry to interrupt.
Yeah,
here's my wish list, Brent, and for any other laser.
All right, let me write it down.
Okay, well, you're getting toward. I was gonna ask, as we're getting closer to wrapping up, for like some of your guys' wish list, some of your future thought. I guess before we get to wrapping up with that, did you have any other thoughts that either you want to jump in with before we do the wish list?
All right. I'll hold off.
I think we covered a lot of different areas today. Probably for some of the folks that listen might have to take a second listen, right? I know I will be afterwards. But you know, I think we covered a lot of things, from automation to the generalizations of what is prefab, what's modular construction. And I think, you know, as a last note, I would just say, you know, specifically to those, whether you're a general contractor or a subcontractor doing MEP and fire protection, look at your current practices today and how you're doing things. And if you're already engaged in prefabrication or modular, or you're thinking of going that route, think about the things we've talked about. You know, is there a partner out there that we can look to get this education, knowledge, or even a process, and be able to start up quicker, right? And have a little bit less risk involved. If you're currently scanning today, whether you're using a FARO or a Leica or a Trimble, how are you using it? And if you're doing prefab and modular, are you using it there? Because if you're not, you're missing out on on a huge opportunity that's not only valuable for you, but also the other stakeholders involved and the customer. So think about those things. I think about them a lot, and you know, I look forward to any discussions that come out of this.
Yeah.
Go ahead. Your turn, Chris.
All right. Well, that's hard to follow up on. I think you did a great job of kind of wrapping things up. I'll take a note off your page there, and just kind of address kind of maybe people who are in the academic world, or who I don't even want to constrain it to that, but people who are just thinking about what's next. And I would just urge you, like, I've had such a great experience reaching out to FARO, and it was sort of just like a Hail Mary throw kind of, you know, thing where I'm just going to send a message. And actually it was listening to a podcast that kind of started this whole thing for me. So
podcasts, they're spreading the education and the connection.
They are. And I think it's this democratization of knowledge. You know, you don't necessarily need to go to a university to learn something. Yeah. Like, I think it's such a huge misconception. I think sometimes it's the opposite. I think it's the academics that can learn from industry. I
also don't want to put academics down, but we were actually just talking about this yesterday. The video of Elon Musk saying nobody needs to go to college to learn anything. You can learn it online. College is for proving you can do your chores. I was like, oh, that's harsh. But
you know what? I can echo that too. And I'm like someone who has I've been around the lap a lot in the academic world.
About to be doctor, right? Dr. Chris?
Yeah, we'll see. I've got my defense coming up, so that's a little premature. We'll see. Hopefully none of my community takes a hard listen through this.
But the best thing with education, the best advice I could give to someone, especially if you're getting into a collegiate program or trade school, you know, with the trades, you're going to get the experience in the field. But on the collegiate side, you know, I've gone back to my campus several times, and my one professor who always invites me, you know, give them advice. Get an internship, whether it's paid or not. Get an internship. You know, whether you stay with that company for 3 or 4 years throughout your undergrad, or if you continue into grad school, do an internship. This is why I'm here today, right? You know, I had a paid internship throughout college. I worked full time throughout college at the same company, and it got me to where I was at today. And it gave me that knowledge that you don't get, right, from college, right? You're going to learn, you know, I went through 8 courses of math, and I got to use a total station on lab number 10 of my survey class. And I was like, when are we getting the laser scanning? And they're like, we're not. So the best advice is get out there and get an internship or work with a company and try to gain more knowledge of that industry while you're getting your undergrad, your grad, or going through trade school. And while that's happening, we can further our relationship with the academic community through these podcasts and webinars, and I'll wait for my wish list thing for the education.
Yeah, sorry, we hijacked your closing.
I will echo just what you were saying, Brent, which I think, you know, as much as I kind of downplay the role of the university, I think there is still a really significant role. Mm-hmm. And I think it's, you know, the fact that we can focus on a specific problem for 3 years or however long, you know, a PhD is, and we aren't kind of confined to the constraints of being in business where we have to get working solutions. You know, that's where I think a lot of breakthroughs do happen. And I'm not here to say that like my research is breaking through. I think I've taken a much more pragmatic approach, which is let's not maybe reinvent the wheel, but let's just try to, you know, innovate rather than, you know, invent. But I think the ability, it's amazing what I've seen just in my amongst my peers of just the focus on one specific problem in a world that's constantly like ding, 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 and like pulling your attention and microwave this and that. I think that there's still a need to just shut everything out, focus on a very fundamental problem and really drive innovation that way. And I think what we'll see if we have a lot more of that, and it has been going on, so I can't say that it needs to start, but the more we have that in parallel with the industry, you know, working on research and development the way they are, that's where we're going to have this true kind of harmonized future where we can develop this technology. It can be implemented. And that connection between academia and industry is significant.
Yeah.
We can't work in silos.
And I think that's where the best use, like, again, not downplaying universities. I think that's where universities are amazing, is like the fact they can spend the time and focus on that stuff. I think the part that when you hear people say university isn't necessary is more the side of, and again, we've been having these conversations internally. It's like, that's not the problem. The problem is so many kids that just come out of high school that are blindly going in, that go for some random degree that they don't really pay attention to, do the party scene and get out and go get a job at Target, like going to a university just because, versus like what the power of a university focusing on certain solutions and problems and innovating and bringing these new technologies in. They definitely have a power there.
Yeah. And you can do that. So talking to undergrads, you don't need to do a master's or PhD to have that kind of mindset of, I'm going to tackle one problem. You can come into your undergrad saying, I have to take courses. I can't get around that, but I am specifically interested in this one thing. And I'm going to have a spin. So if I'm in this class, I'm going to try to, how can this help me in this problem? And I guarantee that when you come out of your undergrad, you're going to be so much more equipped. It's sort of like having, I often hear the MBA through I'm going to botch the expression, but it's like a lived MBA experience of like, I have like a self-taught MBA, and you can have that kind of self-taught master's or PhD of just being curious and thinking about a specific problem. And I think getting out and talking to industry or you making that connection early on is only going to further you down the road.
I didn't go to college, and I have a self-taught PhD in innovation, and I think
there you go.
From Nexus University.
There you go.
See, we're already on to something. Chris, I think that's great advice. I honestly, I think back to my undergrad and kind of go, because I didn't have, I knew I wanted to do civil engineering and surveying, but I didn't go into college with I'm going to do laser scanning, right? I didn't know what I was going to do. I just knew I wanted to follow that path and work towards a PE someday. And I have other ambitions now that I'm in this role, but I think it's great advice for folks who are entering the undergrad program. So.
Yeah. And for some people, it's not like, even for myself, I didn't know what I wanted to do in my undergrad, but maybe university is not the best place to like, I'll figure it out in university. Maybe that's somewhere having like working in the trades gives you that understanding. And then you can say, hey, there's this problem. I'm going to go to university. So, I mean, I think the education of the future needs to change it. Being taught from the textbook is not, it's not going to help us solve the problems we need to solve.
Yeah.
So,
when we were having this talk, I was almost saying like, I think that when kids get out of high school, of course it'd be great if they are ready, when we're coming out of that scenario, kind of have an idea of a field we want to get into, and don't go straight to college. Like go do your internship first. And you're like, okay, this is the field I want. Now I know what I want to go to college for. Because if I went to college when I got out of high school, I have no idea what I would have gone for. I would have had some random degree. But now that I'm in a field that I'm passionate about and I like, now I'm like, okay, well, I could go back because I know what I want to go, further, get education in or expand into. But I think the education system has been so cookie cutter, I think, for so long that it's just this flow, that a lot of people kind of just go through the motions. But trying to start inspiring people to like, man, especially if they're hearing like this type of information and they know that they want to get into construction or engineering or, trying to do some self-education even before you get too far into, college or a university, and kind of pick a route to start pursuing. And you have that in your mind while you're going through that.
Yeah, I even had that too with the co-op program. So that's fantastic, because even within civil engineering, which is the degree I went to school for, I took co-ops kind of across the map. And I think that allows you to say, oh, okay, I spent 4 months doing that, but I didn't spend 40 years of a career that I'm going to be miserable. Yeah. And so I think that should happen outside of just civil. I've seen some schools have a general engineering first 2 years and it allows you to see kind of where your interests are. And then you can, okay, I'm going to specialize here. So I think we just need to keep the university systems kind of evolving to suit these unique demands.
Although a hot day in the sun, humid, in the woods, being bitten by mosquitoes might change your mind about being a surveyor.
Yeah, there you go. Okay.
Hats off to our surveyors out there, though.
I know. Yep.
We love them.
All right. We're going to do our wrapping up then. So back to those questions we were at. Yeah. And you can expand on the wish list however you'd like, but I like to at least ask, with the start of your wish list, like if there was one thing that you see right now that could just be improved, whether it's like a new piece of hardware, an improvement in hardware process, or a new piece of software, or an improvement, or something that you don't even see yet. Like what's something that you see, whether it's specific or an area, what would that be? All right, we'll start with Chris. Yeah.
All right, I'll start. Okay.
All right, starting with the hardware guy.
Okay.
I wasn't going to say hardware. Spoiler alert.
There you go.
All right, so no pressure, Brent. I know we have great ongoing conversations, but here's like if I had this today, it would be amazing. So we've got laser scanning technology. What if there's a way to download the BIM to that device so that it's a smart laser scanner? And as you're scanning, it knows what to pick up in high res, and the rest is just fill in the blanks.
Ooh.
I think that would be amazing. There's ways of getting around that from a post-production where you do a low res scan and a high res scan and you kind of stitch the two together. But if you could have the laser scanner pick up and identify things as it's scanning, it would allow us to solve some of this compression issue.
All right, so we need some AI.
Yes, Dr. Chris.
Scanner.
All right, I'll get right on that.
Thank you, Dr. Chris. Okay.
Is Germany listening? No, I think that's I think it's an interesting wish there, and I'd be curious to know of the listeners how many others would see that as being advantageous. Because with scanning, it's Matt, you've probably talked to other clients about it. I've had customers where they use one resolution, and then others who they change the resolution. But now we're taking it a step further, right? We're redefining the process, and we're
automated registry or automated resolution.
Automated resolution based on the object or applicate. You could
there's
you
a
could
PhD there.
However you want. Yes. Yes, but very interesting wish there. Sure.
Well, and I think obviously there's lots of challenges there and complexities, but I think in my mind when I start, like Brent, you're saying like who think other listeners who thinks that sounds like it would be useful. My immediate thought is probably in the scenarios where you're trying to pick up, like right now we're doing a scan to BIM project where we're doing 1/2 inch conduit throughout this big site. Okay. Yeah. Well, we need those, but it's overkill to run high resolution the whole time
on everything else,
all the other stuff. Yeah. So if it could scan at one resolution for the majority of the building, but when it got to this section, just know to increase resolution on the small elements, dang, that would be sweet.
Yeah.
There we go. Our first customer, Brent.
Well, when we develop it, Matt, we'll send you the first unit to test out. How's that
There
sound?
you go.
So I think wish list for me, I could talk all day about hardware. I've my 5 years at FARO, I've given them my wish list of different things I want.
Okay, you have to share at least part of it. Like, what's one of the things?
Honestly, my wish, I've been working on the prefab modular stuff for 1.5 years now, and we've had a lot of focus on not only templating in the factory but templating in the field. I would love to see where we can merge the scanning and projection technology together. I see a lot of benefits there because the use case for those two I said it wasn't going to be hardware, but okay, it is hardware.
We're doing both.
We're doing both, right? I see a lot of application there, right? When you think about the use case for projection technology in the field, today we use total stations, and they've gotten super efficient over the years, going to the robotic side and being able to do layout without having to have a prism or anything. But I still think there's further development there to be more efficient, where I can, project or template an area that I'm working in without having to mark something, then move down. For instance, hangar locations, right? I can only do one at a time. What I would imagine is being able to have these two pieces merge together and be able to either do an as-built, or maybe that's how I align myself, and then I project, right? And maybe and if you think about the use case for projection, think about how we do concrete today, right? We scan a floor. Well, I think the way that we give that information for those improvements is archaic. It's usually a print, or it's an area that I generalize. Well, we're spending all this time doing floor flatness, and we're only laying out maybe every 10 feet with a total station. Here's the incremental value that I need to change. Why not be more accurate with that? We have the technology today to do that. I can take a projector and I can literally put the contour on the floor within a 1/4 millimeter with text, and I know exactly what to cut or fill on that area. So from a hardware side, that's what my wish list is to see those two technologies come together to be provide a more productive system, right? And there's pros and cons to that, right? We've seen it with systems that are integrated, like the scanning total stations, right? And they have their place. Same thing there. From an idea perspective, I'd like to see more improvement with processes, having things more integrated. And I think we're seeing that in our industry across software platforms and, through Autodesk relationships and relationships with Manufacton or Procore, all those big name companies. I want to see more talking to those software platforms, so that if I'm a client that's using a FARO piece of hardware and I'm using SolidWorks or Revit, and I use Manufacton and I print my own studs, I want all those to talk to each other, so it's streamlined and it's easy, and I don't have to export this and that. That's my wish list, and I think these things we'll see in the future, but they take time. We have to understand the challenges and needs of our customer base, and we take that information. We have these ongoing conversations with these different companies, and we try to solve those problems. So hopefully that's not too much to ask for. We'll see.
I'll write it all down.
Perfect. It's recorded. It's going public. So.
Oh, there we go. I don't need to write it down.
See, you don't have to write it down. So FARO, that's my wish. That's what I want to see. So maybe I'll be part of that. Who knows? Maybe I'll be part of it. Maybe I'll be part of the idea.
Those are good.
Matt, what do you want to see? Hold on, you're not out of this. What do you want to see?
Hey, I'm on this podcast all the time. My wish list is only so long. I mean,
okay. Well, we're on prefab and modular. So what's, as you learn more today, what's the wish list there?
I didn't really think about it, but since we're on prefab and modular, it kind of makes me even just think on the prefab side. Again, the main experience I've had there is really on the industrial, but it's up till now, it's really been still a very manual process of like how you're QCing things, even when you're going to scan it for QC. So I'd probably say kind of like Chris's idea. I want to preload the vessel in the scanner, and then when I scan it, it's going to automatically be able to tell me instead of having to scan it, then take it back to the office, then register the data, and then load it in with a model and try to do a comparison. I just want to load the model in the scanner, scan the vessel, and be able to open it up and see what's off.
Well, Matt, I'm being the role of Santa right now. If you get a hold of Brent, he has this technology, this software called Build It. And I'm not going to spoil anything. You have to talk to him, but it does a lot of what you had asked for. So I'll leave it at that.
Yep. There
Wish
we go.
granted.
Perfect. And I can grant everybody else listening, if you want to try it out, we can get you set up with it. So
that's awesome. Well, we'll be adding some links. We always do when we post these, to, if people want to reach out to you guys individually, want to connect, continue conversations, have questions, we'll link you guys up on LinkedIn, and then of course pages, for website or anything else like that you want to. So appreciate you both joining us. I know we don't get to meet in person at a conference for a while, but if it doesn't happen soon, I think we're just going to put our own virtual conference on and do some networking and stuff. So one way or another, we'll have you guys back around soon.
Yeah, I missed our usual meetup at AU this year, so in person, that is. So
I think
hopefully things will
that's when we met, right? That's when we actually
first did.
Met.
Yeah, we did.
Yeah.
First time in person was at AU. So maybe next year everything will be better, right? We're not far from it. The three of us will be able to meet in person and chat it up,
Awesome.
Or at Next U. That was what I was going to say. It's Nexus University.
There you go.
Yes. Yeah.
Some branding and advertising for you.
Hey,
wow.
The official is not out, but I do think we will end up with a conference. So keep your eyes open.
Awesome. Well, FARO is all in on it, so you have our support.
Well, I appreciate it, guys. Thanks again for joining us.
Thanks,
Matt. Guys, stay safe, stay healthy. We'll talk to you guys again soon.
All right, you guys. Yep. Take it easy. Thanks, Chris. Take it easy, guys.
Yep.
Bye.
Reality Capture Network, bringing the future to you.